All right, so condensing this log, so log base 2, so there's our log base 2, and then whatever's on the inside represents a factor inside the log. If it's positive, it goes on top. So since these two logs are positive, that's why the x and the y go on the top. If the log is negative, the factor goes on the bottom. Now, if you have a number in front, you need to raise that up. So you're going to get ln x squared minus ln y to the third minus ln z to the fourth. And now I can combine this into one log, so ln. And then on top, we're going to get x squared. On the bottom, we're going to get y to the third times z to the fourth. Now, if you just get a number, we need to turn it into a log, and it's whatever that base is there. So, because that's log base 10, what cancels out is a 10. So, we need to put that in front, and then whatever that value is, so in this case the 3 becomes the exponent. So this is going to become log base 10 of 10 to the third minus, and then my log base 10 of x. Now I can combine it into one log, positive, so it goes on top, negative, so that goes on the bottom. Here we need to move that to the top, so I get log base 4 of v to the 6 over u. Now for these, true or false, this first one is false, and the reason being, we haven't learned a single property. We're thinking property of multiplication, but that's log of a times b equals 2 different logs. Right? So you have to multiply the factors. We're not multiplying logs, we're multiplying the factors inside the log. For this one is also false, and the main reason is because the exponent isn't to the entire log, the exponent is only to whatever the factor is. And then for this one, is there any way that I can make it the same? So I'm going to get negative ln. I can bring that x to the top, so I get x to the negative 1. Well, then I can move that negative 1 to the front. Negative times a negative is a positive, and so they are the same, so therefore it is true. So solving these absolute values. So we pretend it's an equal sign. We break it into the 2. Subtract the 1. Divide by 2. And then we're going to distribute. Add the 1. Divide by negative 2. Now, those are the boundary points. So we have to take that. We need to put that on a number line. So negative 3/2 and 1/2, open circle, and we need to test true and false. So we need to take a value, plug it in, and see if it's true. So I plugged in negative 5. The question, is that going to be true? So 2 times negative 5 is negative 10. Negative 10 plus 1 is negative 9. Absolute value of negative 9 is 9. Is 9 greater than or equal to 2? That's going to be true. Now if you plug those, you're going to get true, false, true. So my answer is going to be from negative infinity to negative 3/2 union 1/2 to infinity. For this one, you're going to have to get everything to one side first. Then you can go through and factor it. So x minus 5, x plus 4. Right? Pretend it's an equal sign. So you're going to get x equals 5, x equals negative 4. number line, open circle because it doesn't say equal to. We test true or false. If I plugged in -5, -5, so that's -10, -1, -10 times -1 is 10. Is 10 greater than 0? That is true. If you test the rest, you're going to get true, false, true. So you're going to get -infinity to -4, union, and then 5 to infinity. Evaluating these logs, what power do I need to raise 5 to get 25? So that's going to be 5 squared, which is going to be 2. That 8, what power do I need to raise 1/8? Sorry, what power do I need to raise 2 to get 1/8? And so for that, we can bring that 8 to the top. And I can write that as 2 to the third. And the -1 and the 3 would multiply. So you're going to get -3. Now expanding these logs, this is z to the 1/2. So this is going to become 2 logs, log x plus log z to the 1/2. The 1/2 moves to the front, so you're going to get log x plus 1/2 log z. This, you have 2 factors, so that's log 3 plus log x squared. You can move that 2 to the front.